Today we're going to learn about kites and trapezoids. A kite is a quadrilateral that has exactly two pairs of consecutive congruent sides. Consecutive, remember, means that they're in order, they're next to each other. So we have two pairs of them. Here are the properties of a kite. If a quadrilateral is a kite, then its diagonals are perpendicular. So just like a rhombus has perpendicular diagonals. A kite also has perpendicular diagonals. So BD in the picture is perpendicular to AC. Also, if a quadrilateral is a kite, then it has exactly one pair of opposite angles congruent. In the picture, angle B is congruent to angle D. And this is actually very easy to show. If we draw in diagonal AC, notice that AC is in both of those triangles. Those two triangles are congruent by side, side, side. Therefore, angle B and angle D are corresponding parts of congruent triangles, CPCT. We can see that those two angles are congruent. Notice that angle BAD, angle bad, that angle there, is not congruent to angle BCD on the other side. It's only angle B and angle D that are congruent in a kite. Let's take a look at kite KMLJ. From the previous page, we know by definition a kite has two pairs of consecutive congruent sides. That means JK is congruent to KM. JK is congruent to KM. We know that JL is congruent to ML. A kite also has exactly two congruent opposite angles. I can't say angle J and M because there's more than one angle there, but I could say angle KJL is congruent to angle KML. We know that the diagonals bisect each other. We know that KL is perpendicular to JM. Some things we need to observe about a kite. Let's put a point here. Let's call it P. We know that triangle JKP is congruent to KMP. The reason we know that is the diagonals are perpendicular. We already said that. They share a side. What we have then is hypotenuse leg. That's the HL theorem, hypotenuse leg. So this triangle, call it triangle 1, and this one, triangle 2, are congruent. Because those two triangles are congruent, we have corresponding parts of congruent triangles that we can state here. We know that this angle, let's call it JKP, is congruent to this angle, MKP. We know that this angle, KJP, is congruent to this angle, let's call it KMP. And we can do the same thing below in those triangles. Triangle JPL is congruent to triangle MPL for the same reason. It's hypotenuse leg. The hypotenusae are congruent because they're sides of the kite, consecutive sides. They have a right angle there where the diagonals meet, and they have a leg in common. So triangle 3 and 4 are congruent. That's triangle JPL and triangle MPL by hypotenuse leg. That gives us some other angles congruent. We know that this one is congruent to this one. Angle PJL and PML. And lastly, 1, 2, 3, 1, 2, 3. Angle JLP and angle MLP are also congruent. We got a lot going on in that picture, a lot of congruent parts and congruent triangles. One of the things we do sometimes too is use the fact that we have a perpendicular where the diagonals meet to use Pythagorean theorem. I might give you side lengths. I might say that JM is 20 and JK is 15. So this is 15, JK. And if JM is 20, remember the triangle 1 and 2 there were congruent. That means 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, that JP and PM are congruent. So if JM is 20, each of these pieces would be 10, half of 20. Then we could call KP X, and we could use Pythagorean theorem. There's a problem that does that. X squared plus 10 squared equals 15 squared. X squared plus 100 is 225. X squared is 125. Square root. The perfect square in 125 is 25. It's 25 times 5. Square root of 25 is 5, so it's 5 radical 5, or 5 root 5. I believe the question in the homework asked for it to the nearest tenth, so I don't think it'll take a root. But 5 root 5 to the nearest tenth is 11.2. So x is approximately 11.2. A trapezoid is a quadrilateral with exactly one pair of parallel sides. It can't have two pairs. It has exactly one. Each of the parallel sides is called the base. BC is a base and AD is a base. The non-parallel sides are called the legs, and the base angles A and D are the angles that are next to each other that have a common side that is a base. So A and D are base angles, and B and C are base angles. If the legs are congruent, then just like in an isosceles triangle, it has two equal sides. We'll call those legs also. In an isosceles trapezoid, the legs are congruent, just like in an isosceles triangle. It has two equal legs. An isosceles trapezoid has some specific properties. If a quadrilateral is an isosceles trapezoid, then each pair of base angles are congruent. So just like in an isosceles triangle, you have base angles congruent. Isosceles trapezoid also has base angles congruent. So A and D are congruent, and B and C are congruent. And if a trapezoid has a pair of congruent base angles, if it's just a trapezoid, then we know that it's isosceles because those base angles are congruent. Take a look at this last theorem and notice it says if and only if. Now it's been a little while, but if and only if is a biconditional. Been a while since we talked about that. Remember that in a biconditional, the original statement is true as well as the converse is true if the biconditional is true. That means that this statement says two things. If a trapezoid is isosceles, then its diagonals are congruent. And if a trapezoid has congruent diagonals, then it is an isosceles trapezoid. A trapezoid has a midsegment just like a triangle has a midsegment. In a triangle, we join the two midpoints of the sides, and what we discovered was it was half the length of that side it was parallel to. In a trapezoid, the midsegment is also created by joining the midpoints of the two legs. The midsegment of a trapezoid is the average of the two bases. In other words, you take the lengths of the two bases, add them up, and divide by 2. For future reference, it turns out that the area of a trapezoid is the length of the midsegment times the perpendicular distance between the bases. Let's take a look at some examples below. In the trapezoid on the left, if I wanted to find the length of ST, I could call it X. I know that the mid-segment can be found by taking the average of the length of the two bases. In other words, if I take ST, which I'm calling X, and I add it to 38, and I take the average, add them up and divide by 2, the length I end up with should be equal to 31. To solve this equation, if it was me, I would multiply both sides by 2. That would allow me to cancel these two 2's, and I get X plus 38 equals 62. Then I would subtract 38 from both sides. And 62 minus 38 is 24. I know that ST would be 24. The trapezoid on the right is just a reminder that this is true in any trapezoid, not just isosceles trapezoids. But angle E and angle F, they're not congruent. They are supplementary. They are same side interior angles. Remember that if you have parallel lines, EF is a transversal, that the angles on the same side are supplementary. They're same side interior angles. So angle E and angle F are supplementary. They add to 180 degrees. This is true in any trapezoid, not just an isosceles trapezoid, but also angle H and angle G are supplementary. If I wanted to find angle G right here, I know that 49 plus the measure of angle G is equal to 180 degrees. The measure of angle G then would be equal to 180 minus 49, which is 131 degrees. As soon as I know that angle G is 131 degrees, because this one is isosceles, I also know that angle F is 131 degrees, and I know that angle E is 49 degrees. A reminder, only in an isosceles trapezoid are the base angles congruent. A large part of your assignment is review. I picked a few questions from the homework that are new. This first one is related to the last question we did. Notice that this is an isosceles trapezoid. The base angles are congruent. We automatically know that this one is 66 degrees. If I want angle H, I need to find L or H, either one. I know that angle L and O are same side interior angles. They add to 180 degrees. That's true in any trapezoid, not just an isosceles trapezoid. The measure of angle L plus 66 degrees is equal to 180 degrees. To find L, then, we subtract 66 degrees from each side. 180 minus 66 is 114 degrees. Because this is an isosceles trapezoid, the base angles are congruent, and both angle L and angle H are 114 degrees. Here we have a kite. Quadrilateral YHWZ is a kite. We know the diagonals of a kite are perpendicular. We have a right angle right there. We know that triangle HWK is congruent to triangle ZWK because of hypotenuse leg. They're both right triangles and they share a side. We can use that below too. We know that triangle HYK is congruent to triangle ZYK because of hypotenuse leg. Let's put in some numbers. The measure of YHW is 94. YHW, this whole angle is 94 degrees. The measure of WHK is 45 degrees. Reminder that the opposite angles are congruent, so this one is also 94 degrees. And this angle right here, KZW, would be congruent to the one across the way because the two triangles are congruent. It's also 45 degrees. We can take 94 minus 45, which is 49. So this is 49 degrees, and this one is 49 degrees. And we know that we have these right angles in the center here. We can subtract from 180 because this is 90, and this angle right here, call it x. I know that x plus 90 plus 49 is equal to 180. X plus 90 plus 49 is 139. That equals 180. And if I subtract 139 from 180, I get 41 degrees. So this one is 41 degrees, and this one is 41 degrees. I can do the same thing up here. I'll call that angle y. I know that y plus the 90 right here, plus the 45 right there, is equal to 180. The three angles in that triangle add to 180. That's y plus 135 is 180. And if I subtract 135 from 180, I get 45 degrees. So this angle is 45 as well as this angle. We're trying to find the measure of HYZ. HYZ. That's this whole angle right here. So it'd be 41 and 41. It's 82 degrees. And WZK. WZK. K was right there. I kind of blocked it out. That is 45 degrees. In question 18, we're trying to find a midsegment, the length of segment LX. The midsegment is the average of the two bases. LX, I'm just going to call it plain old X. X is equal to the average of the two bases, and the bases of a trapezoid are the parallel sides. That's 46 plus 64 divided by 2. 46 plus 64 is 110. So this is 110 divided by 2. That means x has a length of 55. So Lx is 55. Question 20 is like the example I did in the teaching. I'm going to call this x again. I know the average of the two bases. The bases are the parallel sides. If I add those two things up, x and 29, and I'm going to divide them by 2 to take the average, add them up, divide by 2. The length I get is the midsegment, which is 24. To solve this, I would multiply both sides by 2 because that allows you to cancel the fraction. X plus 29 is equal to 48. Then I can just subtract 29 from both sides. And 48 minus 29 is 19. So x is 19. LH is 19. This last one is like one I did in the teaching. You're trying to find BC. That's that right there. What I know is that BD, this length, is 40. Remember that triangle BCR and triangle DCR are congruent by hypotenuse leg. That means that this piece and this piece are congruent. And if BD is 40, then each of those pieces is 20. This thing's not to scale. What we want to find is BC. Well, I know that RC is 22, so this length is 22. And it's just Pythagorean theorem. The diagonals of a kite are perpendicular. I can use Pythagorean theorem then because I have right triangles. That's 20 squared plus 22 squared equals x squared, where x is BC. That's 400 plus 22 squared is 484 is x squared. This is 884 equals x squared. To find x, I'll take the square root of both sides. I'm going to flip this around, and we're just rounding to the 10th here. Later on, I'll have you do some of these in simplest radical form, probably when we get to area. The square root of 884 to the nearest 10th is about 29.7. So our answer is 29.7.